Hello, this is going to be a quick recap on formal deduction, which essentially is the way that we can get the validity of a proof without evaluating the truth values. And the idea is that it should be able to be done using a computer. So we do this by taking premises, then we try to get to the conclusion using a set of rules. So we have 11 rules, which I'll just pause here. We have these 11 rules as well as a bunch of theorems like hypothetical syllogism, De Morgan's laws, contrapositive, etc. that we can use to get to conclusions. So I'm going to quickly go over examples because I found that seeing somebody else do it kind of helped me get the flow down. So here's kind of a simple one, and I'm going to do it myself, and I'm going to go through a annotated class version, and I think that should be good. So I'm going to write down the problem here. A implies B, B implies C, deduces A implies C. And so you can see we have the premises here and we have a conclusion here. If there's a lot of premises, what they like to do is they say like let sigma equal the set of premises. In the slides for this problem, I didn't see them actually do this, but I know you can do it. You number each step and you write the premises here and deduces something. So let's start off. We have A deduces B. And we want to get to A deduces C. One tip that they say for implication and conclusion is we want to take the antecedent, whatever is before the implication, and we want to actually assume it. So I'm also going to add A here. So this is by membership. A implies B is inside our premises here. So we're literally just citing that. Now, second step. Rewrite these, make sure you don't leave any behind. And we're going to say A implies A. This is not reflexivity, this is just membership. Once again, membership of this additional premise. See, I wrote A here besides sigma because it's not part of sigma. Now, step 3. What we have is sigma A deduces, and since A is true and A implies B is true, what we have is actually we just get B. So this is another rule. 1, 2, we cite 1, we cite 2, and we say the implication is removed. 4, sigma A implies B. What we want to do now is pull out B implies C. This is kind of like jumping, like, what's the word? This is kind of switching gears is what I would say. So we switch to a different tool we're using, and we already deduced B, and so now we'll use 3, 4 to say that we get C. So what that is 6 we cite 3 and 4 and we remove the implication. We have A, sigma A deduces C. Now what we want to do, hi there.
Hey, what?
Well, now what we want to do is actually we want to remove this from the premises, and we want to put it into the conclusion as an implication, because if we assume this and it gives C, we can also say that if A then C. Therefore, this is what we wanted, and we're going to cite this 5 we're going to say implication plus. I hope you could see that during this. So here's the final proof, and let me just check the actual solution so I'm not feeding you guys garbage. We have membership, 1, 2, implication subtract, membership, 3, 4, implication subtract, plus, implication plus. Yeah, so I got that. Now we're going to go over another example, which I'm being very careful to show you the ones I use, because like sometimes I'm just partial marking stuff. But these are 100% correct, the ones I'm showing you. So we have A implies B or C, A implies not B, C implies not D, and we want to deduce A implies not D. So once again, you see we have assumed A. Okay, we created the sigma and we assume A, and we pull out one of the members, this one, and we do the same kind of thing where we pull out A from the premises using the membership, and what I said here is we need to activate or derive it using membership. Membership, once again, it's not actually one of our 11 rules. It's one of the theorems we use. It's here. I don't have a proof on me, but basically the idea of membership is that it uses reflexivity inside of it. And I'm just going to talk about how you use it. I'm not going to prove it for you. We do enough of that. You can go prove it for yourself. But membership lets us use the items in an assumption. Reflexivity is different because you only have one assumption set. So the only thing in an assumption is A. That was one of the things I was confused about. I thought this would deduce reflexivity. It's not. So now from here, we activate this using the fact that we have A. So now we get B or C. So we cite 1, 2, implication minus. Now, what we want to do is we want to switch gears and use membership. Use the second, the second bit of membership. A implies not B. Now, we have A once again, so we get not B. So 2, 4, implication minus. So now, using step 3 and 5, we use the fact that we have B or C and the fact that we have not B. So this is not B, so it has to be C. And that is exactly disjunctive syllogism, which is saying, where is it? If you know a disjunction is true, if one side is false, then the other one is true. So, yeah, once again, I repeated it here. And so we force C. Now, we use membership to pull out C implies not D. And then we use the fact that we have 6, 7 to remove the implication and get not D. Now, last but not least, we have A here. We did not start with A. We started with sigma and sigma only. So we want to get rid of that. Well, we're going to use implication plus to move it from this side to this side. We have A implies not D. And so this comment is not fully correct. We do need to reset it, but we're just getting to the conclusion. I don't stand by what I said there anymore. So now at this point we're done both examples. Let me just go through the ones we already used. So we used membership, We use implication elimination. We used implication introduction. We used disjunctive syllogism. And so let me talk about these other ones. Reflexivity, once again, you have A and it implies A. I think this is more useful for like the smaller proofs of the other proofs, because membership is super used and membership uses it. Addition of premises, wait, we did that. Negation and elimination is removing double negatives. The replacement rule, I've never used this before. I might need to look into that. So biconditional elimination, you can turn A, B into A implies B, and B implies A. And this is useful to like separate implications and then work through cases. And vice versa. I used this on the exam today, I think. You can do the other way around. Now, and elimination, this is basically saying, okay, we have A and B. So if we have both of those, then we can use A and B separately. And introduction is saying is the other way around. If we've proven A and B separately, we can combine them into a conjunction. Or elimination is if we know that B implies C and not B implies C, then both roads lead to C. What I said to my friend the other day is that if all roads lead to Rome, then we can prove Rome, like we're going to Rome. Like, this is or elimination. Now, or introduction is if we prove an A and B separately, we can form them into a disjunction. And so I think that's most of them. Oh yeah, there's contrapositive, which is also helpful. Like if you have not B implies A, then what you want to do is you want to be like not A implies B, because you negate both sides and you flip it. That was helpful. Inconsistency law, transitivity of deducibility, hypothetical syllogism. This is actually the first thing we proved on paper. And DML. I need to review DML. I haven't used it yet in formal deduction, but I'm trying to keep these videos short and just recap what I know instead of learning new stuff, because if I learn it in the future, I'll just record it then. But yeah.